Picture this. You're standing in a jungle in 1881. The air is so thick with humidity that breathing feels like drinking warm soup. Mosquitoes swarm around your face in clouds so dense you can taste them. The ground beneath your boots is a sucking mud that never dries, never firms up, never gives you stable footing, and in front of you stretches 9 miles of mountain that you've been ordered to cut in half. You're one of 30,000 workers recruited by France to dig a canal through Panama. The man who sent you here, Ferdinand de Lesseps, is a national hero. He built the Suez Canal. He connected the Mediterranean to the Red Sea. He's 74 years old, and he's promised the world that he'll do the same thing here, that he'll slice through the spine of the Americas and connect the Atlantic to the Pacific. But de Lesseps has never set foot in a jungle. He's never seen what tropical disease can do to a workforce. And he has no idea that the mountain in front of you is nothing like the flat desert sand of Egypt. The Culebra Cut, they call it, 9 miles through the Continental Divide. The hardest 9 miles any construction crew had ever attempted. Within 5 years, 20,000 of those 30,000 workers would be dead. Yellow fever, malaria, landslides that buried men alive, accidents that crushed them under falling rock. France would spend $287 million, bankrupt itself, destroy its national reputation, and fail completely. And then America showed up with 100 machines. This is the story of how the Bucyrus steam shovel accomplished what 30,000 men could not. It's a story about the limits of human labor and the dawn of the machine age. It's about the forgotten workers who actually operated those shovels, men whose names have been erased from history while the engineers who employed them became legends. And it's about the price of progress, a price paid in bodies that were buried in unmarked graves throughout the Panamanian jungle. The idea of a canal through Central America wasn't new in 1881. Ships had been sailing around the southern tip of South America since the 1500s, a journey that added 8,000 miles and 2 months to any voyage between the Atlantic and Pacific Oceans. Storms at Cape Horn killed thousands of sailors over the centuries. The route was so dangerous that insurance companies charged triple premiums for ships attempting it. Captains called it the graveyard of ships. And they meant it literally. The seafloor around Cape Horn is littered with wooden hulls and iron steamers that never made it around the point. Spanish conquistadors had dreamed of a canal as early as 1534. King Charles V ordered surveys of possible routes, hoping to move gold and silver from Peru to Spain without the treacherous voyage around the Cape. Nothing came of it. The technology didn't exist. The jungle swallowed every expedition sent to explore. For 300 years, the dream remained exactly that. The California gold rush of 1849 changed everything. Suddenly, there were fortunes to be made on the Pacific coast, and thousands of people desperate to get there. Some walked across Panama on foot, hacking through jungle and dying of disease, just to avoid the 8-month voyage around South America. A railroad was built across the isthmus in 1855, and it was one of the most profitable rail lines in the world because there was no other way to get people and cargo from ocean to ocean. A canal would change everything. It would cut the journey from New York to San Francisco from 13,000 miles to 5,000. It would allow the United States Navy to move ships between oceans in days instead of months. It would reshape global trade forever. Whoever controlled that canal would control the choke point of world commerce. The question was where to build it. Nicaragua offered a longer but flatter route, nearly 200 miles through lake and river systems that would require less digging. Panama offered a shorter path, only 50 miles from ocean to ocean, but it required cutting through a mountain range. The Continental Divide rose like a wall across the narrowest point of the isthmus, and any canal would have to go through it, over it, or around it. Ferdinand de Lesseps chose Panama because he'd built Suez at sea level, and he planned to build Panama the same way. No locks, no water management, just dig a straight trench from ocean to ocean and let the water flow through. He was 74 years old, he was the most celebrated engineer in France, and he was absolutely certain that he knew what he was doing. This was his first mistake, and it would prove fatal. The Isthmus of Panama is not Egypt. Egypt is dry, flat, stable. The desert sand that de Lesseps had moved at Suez stayed where he put it. The weather was predictable. The workforce could be housed in conditions that, while harsh, didn't kill them by the thousands. Panama was something else entirely. Panama is wet, mountainous, and the ground moves. The rainy season drops 100 inches of water on the jungle every year. That's more than 8 feet of rainfall, turning every excavation into a swimming pool and every hillside into a potential mudslide. Rivers flood without warning. The Chagres River, which any canal would have to cross, could rise 35 feet in a single day. Imagine digging a trench and watching the river fill it faster than you can bail. And the rock that makes up the Continental Divide isn't solid granite that stays where you cut it. It's a crumbling mixture of clay, volcanic rock, and decomposed organic matter that behaves almost like a liquid when it gets wet. Cut into a hillside, and the hillside slides back into your cut. Dig a channel, and the walls collapse inward. The mountain wasn't just an obstacle to be removed. It was an active enemy that fought back against every shovelful. De Lesseps hired French engineers who had worked on Suez. These were competent men, experienced men, men who knew how to move earth and manage large workforces, but they had never worked in a tropical jungle. They had never dealt with rainfall that could dump 6 inches in a single afternoon. They had never seen equipment rust overnight or wooden structures rot within weeks. The humidity warped wood, corroded metal, and turned leather belts into mush. He recruited workers from Jamaica, Barbados, Colombia, and France itself. The Caribbean workers came because the wages were better than anything they could earn at home, $2 to $3 a day when farm labor paid pennies. The French workers came for adventure and the chance to be part of something historic. All of them came without understanding what they were walking into. De Lesseps built hospitals and housing. He ordered the most advanced equipment of the time, bucket ladder dredges that could scoop mud from river bottoms and steam-powered excavators that could dig faster than any crew with shovels. He established supply lines from France and the United States. He did everything that a competent project manager would do, and then he sent those 30,000 workers into a death trap. The French understood digging. They did not understand disease. Yellow fever killed workers so fast that new arrivals would sometimes die before their first paycheck. The disease announced itself with fever and headache, symptoms that could have been anything in that climate. Then came the jaundice, the skin turning yellow as the liver failed. Then the vomiting of black blood, the body's internal tissues breaking down. Then death, usually within a week of the first symptoms. The workers called it the black vomit, and they feared it more than landslides or accidents. A man could see a landslide coming. He could run. Yellow fever struck without warning and killed without mercy. Malaria worked more slowly, but just as surely. The parasites invaded the bloodstream and multiplied in the liver, causing cycles of fever and chills that repeated every few days. Workers who might have recovered with rest and medicine instead kept working because they needed the wages, and the disease weakened them until they couldn't lift tools, then killed them over weeks or months. Some survivors carried the parasites for years, relapsing whenever their bodies were stressed. The French doctors had no idea that mosquitoes carried both diseases. The germ theory of disease was still new and not universally accepted. Many physicians still believed in miasma, the idea that sickness came from bad air or contaminated water. They looked for sources of foul odors. They avoided swamps because swamps smelled bad. They had no way of knowing that the mosquitoes breeding in those swamps were the actual killers. The hospitals themselves became death houses, and this is where the tragedy becomes almost unbearable to describe. The French medical staff planted gardens around the wards to make them more pleasant, to give recovering patients something green to look at. They put the legs of hospital beds in dishes of water to keep ants from climbing up and bothering the patients. They were trying to be humane. They were trying to provide comfort. They had no way of knowing that the standing water in those gardens and those dishes was exactly where Aedes aegypti mosquitoes bred, the same mosquitoes that carried yellow fever. Patients checking into the hospital for minor injuries, a broken bone or a cut that needed stitching, would contract yellow fever from the mosquitoes in their own rooms and be dead within a week. The hospital that was supposed to save lives was creating new victims faster than the jungle itself. By 1884, 3 years into the project, the French were burying workers faster than they could recruit new ones. Some estimates put the death rate at 200 workers per month. Others suggest it was higher, perhaps much higher. The exact number will never be known because the French stopped keeping accurate records. The paperwork became too depressing. The bureaucracy of death overwhelmed the administrators. When a worker died, his replacement would sometimes arrive on the same ship that carried away the coffin. The workers who survived developed their own rituals and superstitions. New arrivals were told to write their wills before starting work. Some crews refused to begin digging until they had dug graves for themselves, preparing their final resting places before they lifted the first shovel of dirt. The veteran workers watched the newcomers with a mixture of pity and fatalism. Most of them wouldn't last 6 months. And the digging? The digging was barely progressing at all. The Culebra Cut was the heart of the problem. This was the section where the canal had to pass through the Continental Divide, where the mountains rose 330 feet above sea level. De Lesseps planned to cut this down to sea level, to carve a channel straight through the mountain at the same elevation as the oceans on either side, a channel 300 feet wide and 330 feet deep, carved through 9 miles of unstable mountain. The math alone should have told him it was impossible with the technology he possessed. Every time the French dug into the hillsides dug back. The tropical rain saturated the clay soil. The weight of the mountains pressed down on the weakened layers, and the walls of the cut would simply slide into the channel, refilling in hours what had taken weeks to excavate. The workers would arrive in the morning to find their previous day's work buried under tons of fresh mud. One slide in 1884 buried an entire work train, locomotive and all, under a river of liquefied clay. The men who had been working on that train were never recovered. Their bodies are still somewhere in the Culebra Cut, entombed in the rock that they died trying to move. Another slide in 1885 killed 23 men who were eating lunch at the bottom of the cut. They heard the rumble, looked up, and had perhaps 3 seconds to understand what was about to happen before the hillside came down on top of them. The workers fought back with picks and shovels and small steam shovels that looked like toys compared to what would come later. They loaded rock into rail cars by hand, 1 shovelful at a time. A strong man could move perhaps a cubic yard of material per hour, lifting and throwing 40 pounds of rock with every stroke. Multiply that by thousands of workers, and you have an impressive amount of dirt moving, but not nearly enough. They built wooden tracks down the walls of the cut that had to be rebuilt every time the ground shifted. The tracks would sink into the mud, or twist out of alignment, or simply disappear under the next slide. The engineers kept revising their estimates, kept pushing back the completion date, kept assuring de Lesseps that progress was being made. But the mountain was winning. By 1889, France had moved 30 million cubic yards of earth. That sounds impressive until you realize that the canal would ultimately require moving 232 million cubic yards. France had completed less than 15% of the work. 8 years of labor, $287 million spent, 20,000 workers dead, and they weren't even close. The company was bankrupt. The French government refused to provide more funding. The scandal that followed destroyed careers and sent men to prison. De Lesseps himself was convicted of fraud, though the conviction was later overturned on a technicality. The man who had been celebrated as the greatest engineer of his age became a symbol of hubris and failure. He would die in 1894, senile and broken, without ever seeing his canal completed. But those 30 million cubic yards did accomplish something, though the 20,000 men who died extracting them received no credit. France had proven that the canal was technically possible. They had surveyed the route with precision. They had established supply lines and infrastructure. They had figured out which methods didn't work, which was valuable information even if the learning had been catastrophically expensive. They had paid for that knowledge with 20,000 lives, and all of it would be handed over to America. The United States bought the French equipment and the French research in 1904 for $40 million. President Theodore Roosevelt saw the canal as essential to American power. a way to project naval force into both oceans and to dominate the trade routes that were becoming the arteries of the global economy. He wanted to build the greatest engineering project in human history. And he had one advantage that France never possessed. America had John Stevens. Stevens was not a famous man when he arrived in Panama in 1905. He was 52 years old. Jurisman Ancient, a railroad engineer who had spent his career figuring out how to move things from one place to another. He had built rail lines through the Rocky Mountains. He had supervised construction projects where the logistics mattered as much as the engineering. He wasn't a celebrity like de Lesseps. He was a problem solver. Stevens took one look at the French disaster and immediately understood what de Lesseps had gotten wrong. The old man had seen the canal as a digging problem. Dig enough dirt, move enough rock, and eventually you'd have your channel. Simple, brutal, and completely wrong. The problem wasn't digging. The French had proven that men with shovels could dig into the mountain. They had moved 30 million cubic yards. The problem was that they had nowhere to put the dirt. The Culebra Cut was filling up with excavated rock faster than it was being excavated. Workers were moving the same material multiple times, digging it out of the cut, loading it onto rail cars, moving it a few hundred yards, dumping it, then moving it again when it got in the way of the next day's digging. Stevens saw that the Panama Canal was not a digging project. It was a railroad project. Before he dug a single additional yard of earth, he needed to build a railroad system that could move 6,000 loaded cars per day. He needed tracks into the cut, tracks out of the cut, switching stations, maintenance facilities, and dump sites far enough from the work that the spoil would never have to be moved twice. He also made one other crucial decision. Stevens abandoned de Lesseps' dream of a sea-level canal. Instead, he designed a lock system that would lift ships 85 feet above sea level, carry them across an artificial lake created by damming the Chagres River, and lower them back down on the other side. This meant less digging. It meant controlling the river instead of fighting it. It was a compromise, but it was a compromise that would actually work. He spent his first year building that railroad, and it drove the politicians in Washington absolutely crazy. They wanted to see progress. They wanted photographs of dirt being moved. They wanted to tell voters that America was succeeding where France had failed. Stevens ignored them all. He laid 150 miles of track through the jungle. He built repair shops that could service locomotives around the clock, because a broken-down engine at the wrong place would stop everything behind it. He designed a scheduling system so precise that a train would arrive at the digging face every 60 seconds, wait to be loaded, then depart exactly as the next train arrived. The whole system worked like a factory assembly line, except the factory was 9 miles long and cut through a mountain. Only after the railroad was complete did Stevens turn to the actual digging, and for that, he needed machines that hadn't existed when France began. The Bucyrus Company of South Milwaukee, Wisconsin had been building steam shovels since the 1880s. They started small, building machines for quarries and mine operations, learning with each generation what worked and what failed. By 1905, they had developed the most advanced excavation machine in the world. So on a 95-ton monster that looked like something out of a nightmare and worked like something out of a dream. The Bucyrus 95-ton steam shovel could dig 96 tons of rock in a single 5-minute cycle. Let me help you understand what that means. The shovel's bucket held 5 cubic yards of material, about the size of a small bedroom filled floor to ceiling with rock. A single operator, working levers and pedals from a small cab, could move more earth in 1 hour than 100 men with hand tools could move in a day. One machine, one operator, the output of 100 men. Think about that math for a moment. France had sent 30,000 workers into the cut with shovels and picks. America sent 102 machines with one operator each. The Bucyrus shovels didn't get yellow fever. They didn't need to rest. They didn't panic during landslides. They didn't write letters home or ask for pay raises or die and need to be replaced. They just dug, hour after hour, day after day, year after year. I've seen photographs of these machines at work, and even in black and white they look brutal. They're not elegant, not graceful, not pretty. They're all iron and steam and black smoke, functional in a way that ignores everything except the job. The operator sits in a cab that shakes constantly from the vibration of the boiler, surrounded by levers and gauges, his world reduced to the dance of the bucket and the rock. The sound must have been overwhelming. The hiss of steam escaping from valves, the clang of the bucket hitting bedrock, the screech of metal on metal as the dipper swung through its arc, the rumble of the boiler and the chuff of the engine, and underneath it all, the constant thunder of rock falling into rail cars, ton after ton after ton, all day long. The reach on a 95-ton Bucyrus was about 60 feet from the center of the machine. The operator would swing the boom out over the workface, lower the bucket until it bit into the rock, then drag it back using the crowd mechanism that gave the shovel its digging power. The bucket would fill in seconds, then swing around to dump into a waiting rail car. One cycle every 5 minutes if the rock was hard, faster if the material was soft. 64 cycles per hour if everything went smoothly. That's 320 cubic yards per machine per 8-hour shift, every single day. Stevens ordered 102 of these shovels, the largest concentration of heavy excavation equipment ever assembled in one place. He positioned them in stages along the Culebra Cut, so each one digging at a different level, creating a stepped profile that worked its way down through the mountain. The railroad ran behind them constantly, carrying away the spoil as fast as they could produce it. At peak operation, the Canal work site looked less like a construction project and more like an industrial assembly line, machines and trains working in synchronized rhythm, shovels biting into rock, trains rolling forward to receive their loads, full trains departing as empty trains arrived, dirt flowing out of the cut like water flowing downhill, except this river flowed on rails and moved 1,000 tons per hour. But here's what the history books rarely mention. Those machines didn't operate themselves. The Bucyrus shovels required skilled operators, men who understood steam engines and mechanical systems, men who could feel through the levers when the bucket hit an obstacle, men who knew the particular temperament of each individual machine. Every shovel had its quirks. One might run hot, another might have a sticky valve, a third might pull to one side. A good operator learned his machine the way a horseman learns a horse, anticipating problems before they became breakdowns. Finding American workers willing to go to Panama was difficult. The reputation of the French disaster still hung over the isthmus like a curse. Men had heard about yellow fever and malaria and landslides. They had heard that workers went to Panama and never came back. White American workers demanded premium wages, excellent living conditions, and they still died in disturbing numbers during the first years of construction. So the Americans did what the French had done before them. They recruited workers from the Caribbean. 75% of the Canal workforce came from the West Indies, primarily Barbados and Jamaica. These men didn't operate the steam shovels, not at first. They loaded the rail cars, they cleared debris, they laid and maintained the tracks, they did the 1,000 jobs that kept the machines running, the work that was too dangerous or too dirty or too poorly paid for white Americans to accept. They were paid on a different scale, in local currency worth less than the gold dollars that American workers received. They lived in housing that was inferior, crowded into barracks, while the Americans had individual quarters. When they got sick, the medical care was slower to arrive and less thorough when it came. When they died, the paperwork recorded their nationality, their job title, and the cause of death. Their actual identities often went unrecorded. The official records list them by numbers, not names. Worker 4,247, Worker 8,891, Worker 12,336. The graveyards that dot the former Canal Zone contain thousands of these anonymous dead, men whose labor built one of the wonders of the modern world and whose names have been erased from history. If you visit those cemeteries today, you'll find rows of identical markers, many of them bearing no names at all, just the date of death, and sometimes the country of origin. I've searched for individual stories, and they're heartbreakingly difficult to find. We know that a man named Albert Bannister from Barbados was killed in a dynamite explosion in 1908. The blast threw him 40 feet, and he died before reaching the hospital. We know that Samuel White from Jamaica died of pneumonia in 1909 after working 12-hour shifts in standing water, his lungs filling with fluid while he was still earning his daily wage. We know that workers organized strikes in 1906 and 1907 to protest their wages and conditions, and that the strikes were broken with threats of deportation. What we don't know is how these men felt watching the machines do work that their fathers and grandfathers would have done with human muscle alone. We don't know if they took pride in operating technology that most of the world had never seen. We don't know if they mourned the loss of traditional labor or celebrated the reduction in backbreaking toil. Their voices were not recorded. Their opinions were not sought. They were hands and backs and strong shoulders, valued for their utility and discarded when broken. The machines changed more than just the pace of construction. They changed the fundamental relationship between workers and work. Before the steam shovel, excavation was a matter of multiplication. If you needed to move more dirt, you hired more men. 100 men could move 10 times as much as 10 men, roughly speaking. The human body was the unit of production, and the limits of human endurance set the limits of what was possible. This is why the French failure was measured in bodies. They ran out of living workers before they ran out of mountain to move. After the steam shovel, excavation became a matter of logistics. The machines could dig faster than any number of men. The bottleneck shifted from the digging phase to the transportation system. Stevens understood this instinctively, which is why he built the railroad first. He knew that the shovels would sit idle unless there were always empty cars waiting to be filled and full cars moving away to be emptied. This shift had consequences that extended far beyond Panama. The Canal was the first great demonstration that machines could replace human labor at massive scale. Every construction project that followed learned from that lesson. Every mine, every quarry, every road cut and rail grade and building foundation would eventually be dug by machines descended from those Bucyrus shovels. Even with the Bucyrus shovels working at full capacity, even with the railroad moving 6,000 cars per day, the mountain refused to surrender easily. The same landslides that defeated the French continued throughout the American construction period. The difference was that now there were machines powerful enough to dig out the slides and keep going. On October 4th, 1907, a section of the East Bank gave way without warning. 70 acres of hillside liquefied and flowed into the cut, carrying trees, equipment, and railroad track with it. The slide buried the workings under 40 feet of mud and debris. Workers who had been on the surface minutes before were simply gone, swallowed by the moving earth. The machines that had been digging nearby were buried too, entombed in clay that had been a mountainside seconds earlier. The Americans responded by digging out the slide and continuing. There was no other choice. The mountain would move when it moved. All they could do was move more material than the mountain could throw at them. They brought in additional shovels. They extended the railroad to new dump sites. They kept going. In 1910, another massive slide displaced over 500,000 cubic yards of material in a single event. It pushed the channel 600 feet out of alignment. Engineers discovered that the weight of the excavated material itself was causing some of the slides. The removal of rock from the cut reduced the pressure on one side and allowed the opposite wall to fail. They were, in effect, triggering the very disasters they were trying to prevent. The solution was to dig faster and wider. They cut back the slopes at gentler angles, removing even more material. They drained the hillsides with deep wells to reduce water saturation. They accepted that some slides were inevitable and simply factored them into the schedule. When a slide happened, they added the new material to the total and kept digging. The final excavation figures are almost incomprehensible. The Americans removed 232 million cubic yards of earth from the canal route. Let me try to help you visualize that number, because it's too large to grasp as an abstraction. That's enough material to build a wall 8 feet high and 15 feet thick around the entire circumference of the Earth at the equator. That's enough to bury Manhattan Island to a depth of 12 feet. That's a mountain of rock and dirt that had to be dug up, loaded onto trains, carried away, and dumped somewhere that it wouldn't cause problems. And the Culebra Cut, those 9 impossible miles, bis required the removal of 110 million cubic yards all by itself. Nearly half of the entire canal excavation came from less than a tenth of its length. That's where the Bucyrus shovels earned their reputation. That's where machines proved they could defeat a mountain that had defeated 30,000 men. The canal also required building the largest dam in the world at that time, the Gatun Dam, which created Gatun Lake, the largest artificial lake ever constructed. The lake covered 163 square miles of jungle, drowning entire villages and forests underwater that would carry ships across the Continental Divide. And they built the locks, massive concrete chambers that could lift and lower ships like bathtub toys, each lock gate weighing 730 tons and operating with the precision of a pocket watch. By August of 1914, the canal was complete. But the first ship passed through on August 15th, a cargo vessel called the SS Ancon, carrying a load of general merchandise from the Atlantic to the Pacific. The voyage that had once required 2 months and 8,000 extra miles now took 8 hours and 50 miles. The impossible had become routine. The timing was terrible and tragic in a way that seems almost scripted. On August 1st, 2 weeks before the canal opened, World War I began in Europe. The technology of mass production and mechanized labor that had dug the canal would soon be applied to the destruction of human life on an industrial scale. The same engineering mindset that calculated how many cubic yards a steam shovel could move per hour would calculate how many artillery shells were needed to destroy a trench full of soldiers. The machines that conquered the mountain would inspire machines that would conquer continents. The canal that was supposed to revolutionize world trade opened to a world that was tearing itself apart. And the workers who built it, they went home, those who survived. The Caribbean men returned to Jamaica and Barbados with whatever wages they had managed to save. Some stayed in Panama and formed communities that exist to this day, their descendants still speaking English and carrying West Indian traditions in a Spanish-speaking country. The American engineers wrote memoirs and gave lectures and became famous, their names appearing in history books that would be read for the next century. The machines were different. They stayed in Panama for a while, continuing to deepen and widen the canal as traffic increased. And eventually they wore out or were replaced by newer models. Some were shipped back to the United States for other construction projects. Others were simply abandoned, left to rust in the jungle until they were eventually scrapped for their metal. I've tried to find one of the original Bucyrus shovels that dug the canal. As far as I can determine, none survive in operational condition. There are pieces in museums, static displays that hint at their original size and complexity. There are photographs that show them in their glory, black smoke pouring from their stacks, buckets full of rock, operators leaning out of their cabs to judge the next swing. But the actual machines, the ones that bit into the Culebra Cut day after day for a decade, they're gone. What remains is the canal itself, still operating, still vital, and still handling 5% of world maritime trade more than a century after it opened. The Panama Canal carries 14,000 ships per year through the route that cost 27,000 lives to create. The French dead and the American dead combined. Every container ship that passes through saves weeks of voyage time. Every naval vessel that transits from one ocean to another does so because those workers died and those machines dug. I think about that when I see footage of modern container ports, the massive cranes that load and unload ships in hours, the autonomous vehicles that move cargo without human operators, the algorithmic systems that route shipments around the world. All of it descends from the same impulse that sent the Bucyrus shovels to Panama, the desire to do with machines what human bodies cannot. We've gained enormously from that impulse. Work that once killed men by the thousands is now done by machines that never tire, never sicken, never die. Progress that once took generations now happens in years or months. The physical limits of human endurance no longer set the boundaries of what civilization can accomplish. But we've lost something too. We've lost the direct connection between labor and outcome, the simple relationship where a man could point to a cleared field and say his hands cleared it, where a woman could point to a woven cloth and say her fingers made every thread cross. The machines have given us power we never had before. They've also taken something we can never get back. The men who dug the Panama Canal, the ones who survived and the ones who didn't, they were part of something larger than themselves. They knew it. The letters and journals that survive make that clear. They understood that they were building a wonder, that their work would reshape the world for centuries to come. That knowledge didn't make the work easier or the deaths less painful, but it gave the suffering meaning. Today, we move more earth in a month than the entire Panama Canal excavation. We do it with machines that make the Bucyrus shovels look like toys, hydraulic excavators, and tunnel-boring machines and earth-moving equipment that can reshape landscapes in days. We do it with operators who sit in air-conditioned cabs watching computer screens, never touching a shovel or feeling the shake of a steam engine. Progress, undeniably, improvement certainly, but somewhere in that progress, we stop telling the stories. We stop naming the workers. We stop connecting the things we build to the human beings who build them. I don't know how to fix that. I don't think anyone does. All I can do is tell you about the Bucyrus 95-ton steam shovel, about John Stevens and Ferdinand de Lesseps, about the workers from Barbados and Jamaica whose names we'll never know. All I can do is remind you that every canal and every highway and every building and every port stands on a foundation of human labor, whether that labor was done by hands or by machines that hands controlled. The next time you see an excavator at a construction site, think about the Culebra Cut. Think about the men who spent 10 years digging through a mountain, one 5-yard bucket at a time. Think about what they gave us and what it cost them. That's the story. That's always the story. Machines can do what men cannot. But machines are built by men, operated by men, and exist to serve human purposes. When we forget the men, we lose part of ourselves. The canal is still there, cut into the living rock of the Continental Divide, carrying ships from ocean to ocean, a monument to human ambition and human sacrifice, and the relentless march of the machine age that began in the jungles of Panama over a century ago. The machines are gone, the workers are forgotten, but the work remains.